Algebra, what's going on? So today we're going back to absolute value, but instead of absolute value equations, we have absolute value inequalities. Okay, now they're very similar. There's the same change that's going to occur. Okay, but there's just a little bit of a difference to it. You'll see what happens. It's still not that bad. Same basics of absolute value and same basics of inequalities, just kind of put together as one. And then we still have to graph them at the end. We have a couple examples, so let's get started. So for example 1, we have x plus 2, absolute value, is less than 11, okay? Again, you need the simplified absolute value or else you can't solve it yet. So this needs to be simplified, meaning you can't have something underneath it, you can't add something next to it, you can't have something in front. So we write the first one as is. X plus 2 is less than 11. That's our one inequality. Now we need a second one, okay? Same concept from equations. We would change our number to a negative. We do that, but we also change the inequality sign. Okay, this is based off of what we talked about when the reason you have to flip the sign to begin with. So we have x plus 2 is now greater than negative 11. Okay, now it's pretty basic to solve these. You know, we're going to subtract 2 from both sides on both of them. On the left one, we're going to get x is less than 9. And on the right, we're going to get x is greater than negative 13. Okay? Now, here's the tricky part. We need to graph both of these on the same graph. Okay? If you have like colorful markers, then get colorful with it. You know, whatever you want to do so that you see where the actual solution is, because there's going to be some sort of maybe common area and stuff like that. So, what I would suggest is you make your number line. Okay? Take your smaller number, not necessarily the number that's in your left equation, but your smaller number, so negative 13, plot that somewhere on the left. Take your larger number, put it somewhere on the right. Okay? And then we graph both of these. So this first one says x is less than 9. Now, there's different ways to kind of show it so it makes a little bit more sense. Okay, I'm going to use a combination of arrows and shading. Okay, now some people, you know, like we talked about, they like the arrows, some people like the shading, you know, whatever. So less than, it's just less than, so we have an open circle. Okay, and then that 9 is going to be shaded to the left. And then I do the same thing for this. Open circle again, which, by the way, whenever you're doing the absolute value, they're either going to be both open or both closed. You're not going to have one closed and one open because of this. You're not adding the equal sign to it. Okay? So then here we have greater than, so this one's going to go to the right. And then you should see the common area here will be in the middle. Okay, they're not being shaded away from each other, they're being shaded towards each other. Okay, so you can see anywhere from negative 13 to 9, both of these work. Okay, so that would be your common shaded area. Now, when I say get colorful with it, you could shade one like a green or something, the other one a blue, and then darken the whole common section some other color, or just make it super obvious what it is. Okay, but that is my solution. You have two technical inequalities placed on the same graph. Pause it if you need to, otherwise we're going to get to the next example. Alright, so the next one. I couldn't remember if I labeled it example 1 or whatever, but it's the second one, so it's B. Okay, we got the absolute value of 3x plus 6 is greater than or equal to 12. Okay, again, we have a simplified absolute value, so we're good there. We can separate our original 3x plus 6 is greater than or equal to 12. And then our next one will be 3x plus 6. Flip the sign, less than or equal to, and then we change this to a negative 12. Okay, and there's our two inequalities we need to solve and graph for. Okay, the left one, subtract the 6. We get 3x is greater than or equal to 6. And then we'll divide and get x is greater than or equal to 2. That is one solution. Okay, the next one. Again, if you at any point you need to pause it, just pause it. Subtract the 6. Okay, similar steps obviously. We get 3x is less than or equal to negative 18. Then divide by the 3 again. We'll get x is less than or equal to negative 6. And then we go ahead and graph it. Okay, so smaller number on the left. So negative 6 is on the left. Larger number on the right, so we have 2 on the right. Both of these are closed circles. Okay. Now, this one, x is greater than or equal to 2, so that one's going to go to the right. Okay. And then x is less than or equal to negative 6, that one's going to go to the left. So we have that. Now, since there's no common area, you don't need to necessarily shade something else. Okay, these are obviously just going away from each other. Okay, and that's perfectly fine, because if I took a number, let's say I took 3, okay, and I plugged it in. Well, if I plug in 3 here, I get 9 plus 6, that's 15. 15 is greater than or equal to 12. So that one works. If I took something here, like let's say negative 10, okay, I'll have negative 30 plus 6, so I get negative 24. Well, absolute value of negative 24 is 24, so 24 is greater than 12. That's true as well. Okay, that's the basis of doing it. Okay, so that's it for this video. On the practice, you're going to obviously get a little bit more difficult than that, but that's the basis of it. At some point, you're going to run into something that's no solution for these, and that's fine. Okay, it's just no solution. That's all there is to it. When you run into it, you'll kind of see the difference. At some point, we'll probably have to check it. But that's all I got for you today. Until next time, stay safe out there. Have a good day.